Now, before we get started, are there any questions on the assignments thus far? Because we've had 2 assignments so far, 2-1 and 2-2. I did pass out the assignment for this one here already, 2-3-2, and we're going to be covering part of it today. So any questions? Hmm?
Okay.
Yeah.
Oh man.
They were left over from the PLC stuff we've been doing this morning.
Oh, thank you.
Now, you have a note sheet? Okay. Now, we're going to skip as we finished with this one yesterday. We're going to look at these if we have time, because these, I believe, do not show up on the homework. Make sure. Vertex or X is vertex. Yep, nope. We'll look at these in a little bit, because these are looking at focus and directrix compared to each other, and they work a little differently. So we're not going to focus on those. So the first one I want to look at is this here. Now, we're not going to describe this transformation from the standard equation, but we do want to find several pieces of information. We want to find this parabola's vertex, focus, directrix, and axis of symmetry. And the vertex for either one is still the point h comma k. So that means for us to find any of these, we still need to know the value of h and the value of k. Because for vertex in either form is h comma k. Now the axis of symmetry is x equals h or y equals k. But in either case, we still need h and k. The focus is either h plus p comma k or h comma k plus p. So we still need h and k, but we also need the value of p. And the directrix is either y equals k minus p or x equals h minus p. But in any of these 4, whichever equation we're using, we still need to know the values of h, k, and p. Because if we can find these 3 values, then we can find the information it wants. Now, unlike finding the equation or writing the equation, this one's pretty much going to tell us which one it is. It has one of 2 key characteristics. One, for most of the ones we'll be looking at, the variable by itself is what it's going to line up with. So here we have y equals 1 over 8 times x minus 3 squared plus 2. So since y is by itself is to the first power and x is inside the parentheses or attached to the x squared, it means this version is going to match up to our 1, y equals 1 over 4p times x minus h squared plus k. If the exponent had been attached to the y or was connected to the y, we would be looking at the other version. Because here the square, that exponent is attached to the x, so we're looking at this equation here. Questions on this so far? Now, when we looked at this the last 2 days, because of finding the equation, plugging the information in, when they gave us the vertex or they gave us the focus, we lined it up, we matched it up. What was taking h's spot? What was taking k's spot? What was taking these different spots? Now, if we look at this here, what is taking the spot for k? 2. And since it's outside parentheses, it's exactly like we see it. So the value of k is 2. Now we need to look at h. H is 3. Would it be positive or negative? It would be positive because it's in the parentheses. But if we're also matching it up, inside the parentheses, we still have the x in both, yes? The x's are still the same. Here, it's already minus, yes? In the formula, our equation, it's still minus. So that means the h is just positive 3. The sign in our equation they gave us didn't change. It's still negative, still at minus. So the 3 is positive. However, if instead of minus 3, we had plus 3, then the h value would be negative 3. So we have h and k, yes? Now, on all the previous ones, we had to do something to find the value of p, yes? We had to plug it in an equation. We either had h plus p, or k plus p, or h minus p, or k minus p, and we had to set it equal to a value and then solve. And if we look at this here, well, our 1 over 4p is where the p is located, yes? What is taking the place of this entire fraction? 1 over 8. So we're saying that 1 over 4p is in the same place or should equal 1 over 8. Now, whenever I plug that value of p in, I plug that number in for p and simplify, it should turn into 1 over 8. Yes? Do we see how that works? Yes.
If you like multiply the p, does it only multiply it by the 4, or does it multiply it by like the 1 and the 4?
So 1 over 4 times p. So the p and 4 are connected. So they're being multiplied together.
So
It wouldn't, unless p ended up being 4 over p, ended up being a fraction, then we would have to simplify it that way, yes. Now, for some of these here, we will be able to, or you could possibly be able to look at it and see what the value of p is. Now, I'm going to show you how to do this kind of step by step if we were going to calculate out what the value of p is. Now, the first step in finding the value of p is one, setting it up. That 1 over 4p equals whatever the number is in front of the parenthesis. And it doesn't matter which equation we have. This will always set up this way. And I say the number in front of the parentheses because, as we saw yesterday, the number in front of the parentheses is not always a fraction, because we had one that was just negative 2. So if that was the case, we'd have 1 over 4p equals negative 2. It's whatever that number is. The second step will remain the same. We're going to multiply both sides by 4p. We're going to multiply both sides by 4p. Now, at this step, we've probably gotten used to, we can just, on the left-hand side, cross out the 4p and 4p and simplify there. I'm going to go on and step it out for us. Because when we multiply 4p times 1 over 4p, what it's telling us is that we have 4p over 4p. Because that 4p multiplies with the number on top, the number in the numerator. And 1 times 4p is just 4p. The same thing's true on the other side. We multiply the 4p by the number on top. So we have 4p over 8. On the left-hand side, we have 4p divided by 4p. Anything divided by itself is 1. So the left-hand side reduces to 1. Is equal to, well, 4 over 8 will reduce to what? As we can say 4 over 8 is 1 over 2, or we can say p over 2. Now at this point here, if p is by itself, we're finished, we have the value of p. Is the variable p by itself? Now we have what? P over, how can we reduce the 2 in the denominator? Says we can flip it, we can divide by 1/2, or we can multiply it by 2. Because with fractions, and we'll see this in some of the examples, instead of dividing by it, we can flip it and multiply both sides by it. Because here, if we multiplied it out, it'd be 2p over 2. And 1 times 2 is 2. As we said already, would just be 1p, and p is 2. X equals H. Questions on how we found the value of h, k, and p? H, k, and p. I will say this, the little arrow I'm using is just to say when we plug the numbers in, this is what we're going to get. Now again, vertex, axis of symmetry, focus, directrix. We're just getting that from the sheet. We're not having to memorize this. We're looking back at the sheet. And because we're using y equals, vertex is h comma k. Axis of symmetry, x equals h. Focus, h comma k plus p. And directrix, y equals k minus p. And again, especially on the test, when we do these on the test, I would definitely at least write these out so that we do make sure that you get these right. Because especially, the directrix can be 0, yes. Now, especially on the test when you're filling this in, the directrix, if you get that right, have y equals, even if the number's wrong, you've got half the part right. You will get points for at least having the correct directrix, that it's y equals and not x equals. You will get points if you do have the correct equation set up for axis of symmetry. For this one here, we need it as x equals a number, not y equals. Does that make sense? So some of it, just setting it up correctly, I will give you points for that. Now, out of all of these, the vertex is our h comma k, yes? Our h value is, and our k value is 2. So the vertex is the point 32. Our axis of symmetry is x equals h. So this would be x equals 3. Focus. So the first value is just 3. Now the second value, we have k plus p, which, right, our k plus p would be 2 plus 2, which is 4. And the last one is directrix. Directrix is given to us by the equation y equals k minus p. Well, the value of k is 2. 2 is and that's it. And that's it. That's all we have to do for these. That's all it's asking for. That's all it's looking for. Especially on the homework, do make sure to label which one is the vertex, focus, axis of symmetry, and directrix. Kind of put some label next to it, just to make sure we're not having them all mixed up. Questions on any of this here? Now, one of the things I do want to point out is that the axis of symmetry for this is the equation x equals 3, not just the number 3, okay? Because the directrix and axis of symmetry is the equation of a line, so we need the x equals or y equals. Questions on these here so far? But hopefully you're noticing with these here, even though there is a good bit with all of these, with everything we've done this week, there is a good bit with them. They are all revolving around one of two things. Both of what we did the last 2 days and what we're doing today is revolving around knowing what the value of h, k, and p. Because if we have these three, we know the value of these three here, I can go from our information, vertex, axis, symmetry, focus, directrix, to the equation. Or I can go from the equation back to it, if we have these three here. Now for this one here, y is to the first power by itself, x is attached to the exponent of 2. So that means this is still matching up with our y equals 1 over 4p. Well, 1 over 4p times x minus h squared plus k. I started writing and thinking at the same time and just started copying the problem halfway through. So let's start with h then. So what is the value of h going to be? -2, because since it's plus 2 inside, the value of h itself is negative, because the only way we can change from the formula being x minus h to x plus 2 is if the value of h is negative. And in this case, it would be -2. That's the only way we can change that sign. K would be 1, positive 1. Because luckily, if it's outside the parentheses, it's exactly like we see it. So our 1 over 4p is equal to -1/4. Yes? And again, some of these you may be able to look at it and tell immediately what the value of p is, because I think some of y'all were able to do that on the last one. But if you're not, that's fine. Our first step after getting it set up, now, before I start there, are there questions on how we set this up? Right, because we set 1 over 4p equal to -1/4 because they are in the same spot in that same location, yes? That's why we're doing that. That's why we're doing this step here. Now we need to get p out of the bottom of the fraction. So we're going to multiply both sides by 4p. Now as we saw in the last one, this 4p and this 4p will simplify, leaving us with 1. So we have -1/4, yes? And we're multiplying it with 4. So it would be -1. So it is -1 times our variable p, which is -1p, or just -p. Right? So we divide both sides by -1, or we can multiply both sides by -1. And our -p divided by -1, well, negative divided by a negative is a, and anything, so p divided by 1 is just p. It doesn't change it. On the other side, 1 divided by -1 is, so the value of p is -1. Make sense? So let's start with vertex. I'm going to do these one at a time because we did them all at the same time last time, or we actually did them one at a time. I just listed them out. So vertex is our point h comma, so -2 and 1. H goes first, k goes second. No matter which equation, h always goes first, k always goes second. now our axis of symmetry. Yes, because x equals h, so x equals -2. Focus is going to be our h, comma, so the h would be -2. Now our k plus p, I'm going to do this off to the side, would be our 1 plus -1, yes? Which is 0. And lastly, so for this here, the equation y equals k minus p, yes? So k minus p would be negative, or not negative 1. Well, the value of k is 1, minus p is -1. So if it's a if we subtract a negative, 1 minus -1, it becomes positive, which gives us 2. Questions on this here? Now the next part I'm going to say more, hopefully help you all feel better, especially when it comes to the test. I think we feel pretty comfortable with finding h and k, yes? Looking at all this here, how many of the spots actually required the p value? Just 2, yes? The y value of the focus and the other half of the directrix, yes? Everything else in red, either 1 came from the formulas themselves or h and k. And let's just say I did a point apart. So the vertex would be 2. The axis of symmetry would technically be another 2, x and the number. Focus would be 2, and the directrix would be 2. So 2, 4, 6, 8. I don't think it'll be quite that. It might be a little less, but 6 out of 8. That's still a good portion. And the other thing I want to make sure kind of we're seeing is that all of this here is just finding the values of h, k, and p, because once we get those, we plug it into the general form and simplify where needed. Questions on this here? We're ready for the next one. What is different with this one here? It's x equals. So that means the general form for this one here is x equals 1 over 4p, parentheses, squared plus h. And just like with the previous one, we still need the value of h, we need the value of k, and we need the value of p. Looking at this one here, what is the value of h? Because x equals, the h is now outside, and the k is inside. Yes, because h is outside, our plus 1 is outside, it's 1. K is inside the parentheses. Since it's y minus 3, it's positive 3. Yes. Yeah, that's what we'll get to, but 1 over 4p is equal to 1 over 16. To solve that there. And one thing before we start solving p, if you want to go on and start, you can. But I want you to notice the fact that the h and k did flip. Yes? And that is, there's a significant reason for it. Because if we talk about the translations left and right, we always plug that in the spot for h. Yes? And this is going to hold true for the rest of equations when we talk about applying numbers or applying stuff to a function, a formula. H is always going to stick with x. y and k are always going to stick together. And it works with that with circles, parabolas, ellipses, they always stick together. Well, on the last few, where was y? Y was outside the parentheses, yes? And k was also outside. X was inside, H was inside, yes? Now this time y is inside and k. X is outside and they kind of stick together that way. Does that make sense? Now, when we get to the vertex, I'll point that out then. But our first step in solving for this is still multiplying both sides by 4p. Our 4p will simplify on the left, leaving us with 1. Because with multiplication and division, we cannot reduce it to 0 unless the numerator is already 0. So we multiply the 1/16 by 4, which I think you're almost there. 1 over 4. Mm-hmm. Yep, so it would be p over 4. Mm-hmm. So, So what we did is when we multiply a number by a fraction, it always multiplies with the numerator. Because the denominator for its 1, we don't write it in. Because if we did, it'd be 16 times 1, which is, and the 1 times 4p is 4p. Now 4 over 16, will it reduce? Yeah, because there is a 4 in both. The 4 in the numerator will become 1. And if I reduce the 16, it would reduce to 4. So we have p over 4. Now we can't plug p into the calculators, either one of them, the graphing or the 30xs, because both of these calculators need a value for it to evaluate. It lets you plug variables in, but it has a set number assigned to them. Most of the time it's 0. So if I did plug in 1/16 times 4p, the calculator really sees it as 1/16 times 4 times 0. Then it would just say it's 0. It can't do variables. That's just an expression. Any other questions on this here? Now we do need to get p by itself, yes? Yes, because we're saying p over 4 is the same as what? P divided by 4. So to undo division, we can use multiplication. The 4 and 4 will simplify here, telling us that p is 4. Now, if you need a way to check to make sure you got the correct value of p, well, we said at the beginning what? 1 over 4p was what? 1 over 16, yes? In the calculator, I could put 1 over 4 times 4. 1 over 4p. And we should get 1/16. Is that what we get? Yeah. Because with this here, if you want to check it, we can plug it back into the original formula where it's at and see, do we get the correct value? And here we did. Vertex is the point h comma k, yes? What's the value of h? And the value of k is? Now, even though the location of h and k flipped, because they did flip for this one here, compared to the last one, yes? Yes. Did they flip on the vertex? No, it's still hk. The vertex points still stay the same. Because that's one thing I've seen over the years, that you'll want to flip the vertex points. No, it's still h and k. Axis of symmetry. Yes. So this one here, it's y equals k. So y equals 3. Next one is the focus. And now we have h plus p comma k. Well, our k is still 3. But we do need to find out what the first one is, our h plus p, yes?
It'd be 4. Oh yeah, it's 5.
H plus p, well, h is 1, p is 4, and 1 plus 4 is 5. And the last one is the yes. So x equals h minus p. So our h minus p is 1 minus 4, which is indeed negative 3. Because 1 minus 4, which one's bigger? Yeah. Well, if it was 4 minus 1, it would be 3. But 1 minus 4 would give us negative 3. Now, even though we switched from y equals to x equals for these here, did it change anything in what we did? No, it was the exact same process, the exact same steps. We did the exact same thing, yes? And that's one thing I want you to hopefully be taking away from today in the last 2 days, is that even though it looked different, we were given different things, we still did the same processes. But our main goal with any of these was to get what 3 values? H, K, and P. So yeah, we don't have time. You know what? We're going to spend one more day, because I think doing at least 1 or 2 more of these is going to be helpful. Yes? Yeah. Okay. We're going to spend one more day. I didn't plan on spending 4 days on this, but I think this is going to be helpful, because this here, a lot of students in the past have struggled on these. Right. There is a lot going on, but there's also not a lot at the same time. I do.